All right, you ready?
Yeah, as ready as I'm going to be.
I was going to say, as ready as we're going to be, right? Okay, we're starting.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to the All Hazards Consortium's educational webinar entitled Understanding the National Power Grid and How It Impacts Timeframes for Power Restoration. My name is Tom Moran, and I serve as the Executive Director for the All Hazards Consortium, 501c3 nonprofit focused on homeland security, emergency management, and business continuity issues in the Mid-Atlantic and Northeast regions of the United States. I'll be administering today's webinar, but before we begin, I'd like to just provide a couple of housekeeping items to let you know how you can participate in today's call. This webinar will be recorded for use by the consortium and the multi-state fleet working group members and other partners. Everyone who's registered will receive a link to the webinar and the webinar recording after it's concluded, and the slides as well. If you only dialed in from the audio portion of the webinar from your car phone or office phone, you came in as a muted and listen-only member only. If you logged into the webinar from your computer via the web platform and dialed in with using your PIN, your phone has been muted upon entry. We will reserve time for question and answer at the end of the webinar. There are two ways you can participate during this webinar. One is to simply raise your hand by clicking on the hand icon in the window panel that appears on your screen. And we will unmute your phone, provide you with a 2-digit PIN to unmute your phone if you want to. The easiest way for us is to send questions to the webinar staff through the questions panel. Just type your questions in at the bottom of the little window and click send. This is the All Hazards Consortium webinar series entitled Understanding the National Power Grid and How It Impacts Timeframes for Power Restoration. To kick things off, I have the honor of introducing our speaker today, Mr. John Shaner, an Emergency Management Manager for Pepco Holdings, Inc. John has been involved in the electric sector for 35+ years and is currently serving as the chair for the Multi-State Fleet Response Working Group, a recently formed private sector working group comprised of owners and operators of critical infrastructure across many sectors, including energy, telecommunications, transportation, food, water, medical, retail, chemical, information technology, and banking finance. Before we begin, we'd like to thank our partners from PHI, the Edison Electric Institute, the State, Local, Tribal, Territorial Government Coordinating Council, the Regional Consortium Coordinating Council, and the Regional Catastrophic Preparedness Grant Program participants around the country. Of course, we'd like to make sure we, again, extend our thanks to John Shaner and the Fleet Working Group members who helped put this educational information together. So with that, I'd like to introduce our speaker, Mr. John Shaner. John?
Well, welcome and good afternoon, and thank you for having me. The next slide will have my name and will have my title on it, and that slide will be followed by the word NERC. And I wanted to explain that because I've had some people say, hey, do you work for NERC? And the answer is no. That NERC is a designation on how within our company, PHI, how transmission information can be communicated and what you've been trained on in knowing what information can be communicated real time and to whom. So I just wanted to clarify that up front. The next slide, please. As I put this presentation together, my past experience, I've had substantial years in system operations as a system operator, writing emergency plans for reliability, system restoration, and I taught our system operators to get certification in their continuing education hours when it comes to the bulk power system, the grid, the transmission, whatever we want to call it. And as I went through that, you know, I've taught line personnel, I've taught substations, I've educated executives on it, a wide variety. I don't want to come across as a subject matter expert. I have experience in this field, and I've worked this field but I'm sure with the diversity on the phone, there are those of you that have as much, if not more, knowledge in this area than me. And at the end, you'll have my contact information. I would very much appreciate it. If there's something that I may have said that needs more clarification, please send it to me. But the complexity of this issue really took me back to where do I start not knowing the people on the phone and so forth. So what I did is, let's start off with a basic understanding of the grid, bulk, power, or transmission, whatever we want to call it. Then let's talk about some terminology that's used within the industry, a very short list. Then talk about the regulatory body and other groups that are involved in when it comes to the bulk power system, the generation, the transmission, and then being stepped down out to the distribution. Then we can't go without talking about limitations or mitigations of the grid, capacity, scheduled outages, those type of things. There's 3 emergency plans I really want to touch on: the reliability, system restoration, and we'll kind of show, especially with that schematic that's below here, how that ties in with the 3 areas of the grid. Then priorities, how priorities change when you move from a restoration into reliability and possibly a system restoration. Some historical events such as the '98 ice storm in Canada and those type of events in Texas, the lack of generation due to windmills, we'll touch on that. A very short description of system restoration, then how we prepare on a yearly basis for the summer activities. Next slide, please. As I talked about the NERC designation behind my name, a question comes up is, why don't we talk real openly about the real-time information going on with the transmission system to possibly let's talk about the government. In that case, there are standards of conduct, and we have to understand that real-time information can give some advantages to the marketing side, especially if you as an electric utility have marketing embedded into your corporation. So that brick wall has to be there on what information is communicated when. Once the information is made public, that communication can occur rather easily. But until that communication is put out there in a public forum, dealing with capacities, flows, prices, curtailments, balancing, maintenance activities, and scheduled outages, those have to be treated as confidential information and treated that you have to make it public. Next slide, please. So to give an overview of the transmission system, the bulk power, the grid, basically bulk power is defined as 100 kV and above. Transmission can go as low as 69, but in some cases it goes as low as 23, depending on how the line is used. If the line is moving energy from one substation to another, you could perceive that as transmission. But when we start talking with our regional NERC entities, with our RTOs, ISOs, and I'll explain those in a minute, we talk about bulk power, and that's 100 kV and above. So if you look at North America, that includes Canada, we're looking at 3 major systems. We're looking at the Western Interconnect, which down in the lower right-hand corner is the pinkish or the orange color. Then you're talking about the Texas or the ERCOT grid, which is basically Texas. Then the remaining part of it, the blues, the purple, and the dark blue, that is really your Eastern Interconnect. And while there are some DC lines, some limited interconnects between these different regions, those regions are really set up to operate independent of each other. And so those are our interconnects. Now, Quebec is an interconnection. It could be the 4th one, but many times it's looked at as part of the Eastern Interconnect. Next slide, please. Some terminologies to consider and look at are what ISOs, RTOs. ISO is Independent System Operator. RTO is a Regional Transmission Operator. The main difference between those two, those are independent agencies or private sector groups that actually control, monitor, they do the balancing authority type activity, the transmission operator type, the generating operator responsibility, the balancing operator authority, all falls into these groups. The main difference between ISO and RTO is really the footprint. In many cases, an ISO is made more state-specific, not always, whereas a regional transmission operating group is really a region. And using PJM as an example, Pennsylvania, Jersey, Maryland, a regional transmission operator, their footprint is up in the Northeast, and it covers quite a few states. And then you got your reliability coordinator, the RC. I already talked about the balk power. System restoration is a partial or total collapse. Doesn't mean it's a total blackout. You could have an area that blacked out and the rest of the system has islandized away from it. Black start is starting of the units, and the cranking path is using your transmission system to start power generating units. Next slide, please. So when we look at the regulatory body, now not all these are regulatory agencies, but let's kind of look at the U.S. Congress gave FERC the responsibility, the authority for over the transmission, the balk power, and I do want to be repetitive in this. When we talk about the grid, you know, and just kind of removing the distribution a little bit, we're really talking about the balk power, the transmission, the EHV, and you know, depending on how you use that term, you're looking at voltages anywhere from 23 kV up to over 700 kV. So it's a pretty substantial system out there. FERC was assigned the responsibility to making sure that there is some reliability brought into our grid, which they have done a pretty good job of. Go back one slide, please. Then you have NERC, which is responsible for developing these standards that the utilities, the generating plants are responsible to adhere to maintain a reliability system. That ranges from control systems to vegetation to emergency plans. It's a wide range of standards. And the electric sector has a lot of input in that, utilizing our subject matter experts. Then you have your NERC is broken into regions, and those regions actually align to, and I'll show you that in a minute, to the Western, Eastern, and Texas interconnections. Then, as I mentioned, you have your ISOs, RTOs that have responsibility to the NERC for standards, and then the electric companies, usually what we call transmission owners, your generator owners, that also have responsibility to these NERCs and to maintain compliance. Then in many cases you have states that have regulatory and have requirements around the transmission. Next slide, please. Looking at the NERC footprint, you can see how it aligns with the interconnect. You have the WECC over to the left. That's really the Western interconnect. You get the TRE, which is the Texas interconnect, or ERCOT, and then you have the rest of them that are your Eastern interconnect. And of course, as I mentioned before, the MPCC is Quebec, which is considered part of the Eastern interconnect. Next slide, please. What are the limitations and how do we mitigate the grid when we talk about energy? Well, in the most part, our generation has to be generated to meet the load with some reserves. And basically, when we talk about reserves, we're talking about a couple different types, but basically those reserves are there in case you have an unscheduled outage of a generating unit, and that way you have reserves to fall back on. But in the most part, the generation has to meet the needs of the load. We have a very complex system for monitoring, controlling, protecting the grid, from the relays within the power station to protect the generating unit, to your relaying systems on the lines going through the substations, and even out on the distribution. If the demand exceeds the supply, before the worst case scenario occurs, we have emergency plans, operation plans in place. You can have curtailments. You have to do one of two things: either add generation or reduce load, and that could be due to loss of generation, a peak load increase, unexpected increase, which we try to schedule for on a regular basis, or loss of lines that move the generation from the generating point to the load point. So a lot of things can occur. But the worst case scenario is you have a partial or system or a total collapse. Of course, to reduce this, we have the interconnected regions networked. We have alternate flows. Now, when it comes to transmission and distribution, and that's a big thing to remember. Distribution lines, run up and down or under the ground on almost every street, whereas transmission lines or the bulk power system, you have alternates, but you don't have as many just because they cover a bigger footprint. People don't want those lines in the backyard in a sense. Next slide, please. This is important to me because we need to talk about emergency plans, and these are plans, and these are generic descriptions. I'm not going to read it word for word, but we have probably 3 good plans, and they could be in numerous manuals sitting on the shelves. Emergency operations really focuses on the day-to-day operations. We're talking about, okay, we're monitoring the load, we're monitoring the system. If something unexpected happened, what can we do to mitigate that? In many cases, your N-1, N-2 things are occurring, and those are contingency plannings prior to taking something out. So saying if I have a scheduled outage and I'm taking this piece of equipment out, if something else happens, what does that do to me? You run that study before you take that equipment out, and if your system is still reliable, you can go ahead and proceed with that. If it's not, then you cancel the job. But these systems entail customers that have volunteered to curtail under certain conditions, voltage reductions, rotational distribution interruptions. That's where you rotate circuits to reduce load so that each circuit isn't impacted for long durations. And the worst case scenario in the emergency operation plan is probably your load goes up, you lose the generation, you have to shed the load now, or the system's going to start to collapse. In addition, you have automatic relaying out there that does this automatically. So before an operator even has time, or our RTO has time to think, you may have what we call under-frequency relays out there isolating load. System restoration basically says, okay, if the system goes down, partial or total, how do I get it up? These system restoration plans talk about units that have black start capability that can start up from no energy, and not every power plant is like that. In fact, not many are. And then those plants are used to start other plants while we're using load to stabilize the generator. So this plan really talks about getting the grid back in, getting the backbone of the system back in. The restoration is what we do on the day-to-day activities when we have those thunderstorms, when we have those other events. When we start getting into big events, in fact, I'm going to hold off there because I think the next slide is a question that may ask you something. So I'm going to ask you to answer that. So the next slide, please. Well, before we go to that, I guess the next slide is talking about those emergency conditions. And I do want to touch on this, and we'll come back to the emergency plans. But some of those emergency plan conditions are basically, hey, like I mentioned before, generation doesn't meet load peaks, or to transfer the lines to transfer this energy isn't there for some reason. And then you have your ISOs and RTOs issuing alerts, warnings, actions. Those are if you have advance notice or you think going into tomorrow you may have a heavily loaded day. The ISOs and RTOs may issue alerts saying be prepared, we may be going into this type of emergency operations. You know, one of the questions is, that I think of is, do we communicate this to the public sector? And what the public sector should be engaged with the RTOs and ISOs, especially in the EMA level. And in addition, the electric utilities have responsibilities to communicate to our public sector. Transmission securities really talks about those other heavy loads, load voltage controls, the interconnection reliability if we hit limits there. Then we get into weather and environment, sabotage and terrorism, and then disturbance conditions. Next slide, please.
At this point, we're going to take an audience poll. So we invite you to look at your screens here. The question for you that are on the phone, at this point, do you feel that a storm event could have an operating utility in all responding when all three plans, emergency plans, system response, and restoration plans? We'll give you folks just another 30 seconds or so to complete your answers, and we'll jump back on the webinar. Okay, I think we got everybody's answer.
Okay. The answer I see here, it says 85% yes, 1% no, 14% I don't know. The 85%, you're totally correct, and I'm going to talk about this next. So, you know, you think about it in 1998. I'm going to come back to this again in a brief, but you had an ice storm in Canada and northern U.S. that we saw ice that was up 3 inches in diameter on the wires. You know, while we have built our facilities to specific requirements, and in many cases, many of the utilities, such as the Canadians, since they're up north and deal with the ice and snow, have exceeded those requirements. That type of stuff brought down wires, brought down towers. You know, we see it during hurricanes. Hurricanes don't just pick on distribution. Whatever's in its way. Tornadoes, while it's limited to a smaller footprint, it does the same thing. It doesn't determine, hey, I'm going to leave the transmission alone or bulk power. I'm going to pick on the distribution. So we are operating on probably on more often than many people think between the 3 different plans: emergency operation plan, and system restoration and restoration. And it's not that the system collapsed or that we have a load issue at the time. It's as we're building the system back up, we may have lines coming in that have a capacity to serve so much load, but the load that wants to come on because people want their lights on as soon as possible exceeds that capacity. In that case, we have to move to an emergency operation plan. In the Hydro-Quebec area, when they had that ice storm, they actually the loop around the city, the high voltage loop, actually collapsed in the sense, and they had to go to system restoration in the sense of getting the bulk power system back up. So that's why, yes, you're jumping back and forth. And you know, we as a utility, and I'm going to talk to myself on this one. We have, through the years, segregated or divided distribution from transmission from generation. A lot of that has occurred because our organizations are somewhat siloed in those areas because of the different compliances and requirements in those areas. In many cases, when we talk to the public sector, in many cases we're just focused on the distribution, the critical customers' priorities. And it becomes real difficult when we have to reallocate resources from getting the customers back on and focus on the reliability, because if we don't do that, the lack of reliability may cause bigger outages. So we from the private sector have to do a better job communicating that, and we are working hard to do that. Next slide, please. So, Tom, we have a question here.
Yes. Can you hear me, John?
Yes.
Okay. Yeah, the question here for the poll is: could you expect normal restoration priorities to change from a storm event if procedures are required to maintain reliable grid operations? We'll give you folks just a few more seconds to answer, and we'll publish the results. Okay.
And what I'm seeing is 72% said yes. We had 19 that said no, and 9% that says I don't know. And the circumstances are different. I'm going to go through this, but the answer is yes. The priorities can change, and I'm going to demonstrate that to you through the next 3 slides. Next slide, Tom, please. Now, when we talk about generic priorities, and remember, I'm not getting into the details where I'm listing in detail the hospitals, the nursing homes, those type of things, the water facilities. I'm really giving a generic here. Generally, on the restoration side of a thunderstorm activity or an ice storm, when it comes to distribution, we're looking at first of life and property, those things that cause a threat to either a person, people, life, or property. And that could be, example, a wire down. If we have transmission problems, no matter what we do on the distribution side, it's not going to get the power back on. So we have to focus on, hey, what's our transmission system impacts are. While it's less likely they're going to be impacted to the extent that distribution is, there are times that they are impacted, and we have to look at that in our part of our assessment. Then the substations. If there's damage at the substation, if a tornado goes through and is a direct hit, and we've had them direct hit on towers, direct hit on substations, you either have to work through an alternate feed or you have to focus on that as a priority. And then you get into your main distribution lines, the 3-phase lines going down or underground, and then your taps from those lines that feed down the street, and the services to the individual. So that makes sense. And then next slide, please. Putting a little bit more detail to this, those hazards, we're talking about fires, we're talking about wires, vehicles that hit a pole, the wires laying on it, those type of things. Substation feeders, that's going to pick up a large amount of restoring the substation, and main feeders is going to pick up a large amount. Then we get in, and remember, we have numerous crews working on different levels of these priorities. But then the critical services, hospitals, emergency services, many of them have 2-way feeds, if not 3-way feeds, and in addition, they have alternate independent generation because they know their criticalness to the community is to that level. communication facilities, water, sewage, nursing homes in there, but nursing homes aren't always on the main three-phase line. Then we go after those largest blocks, and remember the schematic coming out of the substation, that main line. When you get that in, you're going to get the large blocks in. Then you get down to the individual customers, and this is where you start differentiating a lot of times between those people that are on some sort of life support type, and then the regular customer like me would be a last customer to get restored if I was out on the end of the line. Next slide, please. When we get into a transmission or bulk power system, we have to look at things a little different, and we have to look at, if we go into the emergency plan that we've brought into an event to sustain voltage, to control load, we have not been successful, the worst case scenario. We have to, the system starts to go down. But when that occurs, a lot of automatic controls start kicking in and try to isolate the system. Once that occurs, there's going to be patches of the system back up. You have to stabilize those. You have to get out there and recognize that, hey, I may have too much load in this island where I have this generator, and you may have to reduce load. All that has to be going on. And then you got to develop a strategy. What I just showed you is your whole list of priorities change. While, yes, the wire down is a hazard, and we do have to address that, but the main hazard here is the system went down, and we have to get the system back up before we can do anything else. And, one of the things that's not listed on here and that's in everybody's plan is nuclear power plants. Getting station service to nuclear power plant is probably pretty near to the top of the list. Next slide, please. I think you have a question here, Tom.
Thanks, John. The poll is, can you expect issues on the grid to impact distribution restoration timeframes in your area? John, why don't you go ahead? We may have had a misfunction on that.
Okay. I'm going to give you my answer, and see if everybody else sort of agrees or not. The answer is yes. When you start getting, depending on the event, I'm going to show my age. You go back to Katrina. They had massive transmission damage. You go up to 98 to the ice storm. Again, you have transmission problems. And this isn't, this Hurricane Sandy. We had transmission outages that had to be addressed. So the answer is yes, it can impact. And one of the important things is for both private and public to have an understanding of the transmission system, how the generating, transmission, and the distribution is really all one system. If you start impacting the reliability of the grid, it's going to have an impact on the distribution. Next slide, please. In my past years when I taught classes to line personnel and electricians and substation personnel and those type of people, this was a 6-hour class, so I'm condensing this into 4 minutes. And again, I recognize the fact that there may be far better subject matter experts on the phone. But when you start looking at system restoration and blackouts, what causes that? Hey, it's like our vehicle. When you buy a new vehicle, you pull maintenance on it, but, no matter what, there are things that happen as it ages, no matter what maintenance you pull on it. And there are replacement dates on equipment, especially on the electric sector when we hit a certain level. But the faults do occur. Lightning strike to a transformer, direct lightning strike. You can have relaying or for special protection that has been tested time over time over time, and when it's called upon to operate correctly, there's a problem. We have weather other than lightning, as I've been driving out, the ice storms, the tornadoes, the hurricanes. You have lightning itself. Lightning is 4 times the heat of the sun. It can strike multiple times in the same place. That's where you get the flickering. So it's not just one lightning strike, and many times you have the same strike. And what's more attractive to lightning than the wires in the air or the electric or the substations, no matter what. Then you got your solar magnetic disturbances, your sun flares. We have equipment out there for that right now. And then we have our operators. I'm human. I make mistakes. And our people, no matter how much we train them, qualify, but I do have to give our people a lot of credit. Those are becoming less and less of the event. Next slide, please. And I'm not going to go over this chart, but I wanted to just show you that when it comes to system conditions, major disturbances, again, this includes generation, transmission, distribution. It's not limited to the U.S. or North America. Some of the bigger outages you can see here have been across our oceans. Some of these have been due to scheduled outages, and that's a good example to give you. When we schedule outages on equipment, that load has to be carried from someplace. And as I explained to you, you have your ISOs, RTOs that are studying the outages. In many cases, scheduled outages have to be scheduled a year in advance and has to be coordinated among different utilities through the RTO or the ISO to assure that the reliability doesn't change when this outage occurs, either for maintenance, reconductoring, improving the infrastructure, many reasons there. Over in Europe, there was a situation where they had a scheduled outage, and the scheduled outage caused overloads, and they actually collapsed the system pretty substantially. And you can see the one in 2003, that's storms, but they had the same footprint with the same number of people due to that scheduled outage. Next slide, please. I kind of want to go into a couple examples. I'm going to drive to the end so we have time for questions. Is again, the Canadian ice storm. And really what I want to drive out here is you see the distribution pole transformer down. You also see the towers down. And Hydro-Quebec did a great job when they came out of this event, and so did many of the other utilities in creating an educational video on this and what caused it, the amount of ice, and what caused this type of devastation. If you ever have an opportunity, I can stress strongly to review that video. Next slide, please. Here's an example. We have a diversity in generation. We have coal, we have hydro, we have nuclear, we have wind, and we need that. We have solar. We need that diversity. We need to be conscious of our environment. I'm a total supporter of that. But here's a good example that you can't be dependent on just one source. And here's an example of, you usually have peaks in the morning when people are tending up, when in the industry, commercial, residential industry is picking up, you have a peak in load. And then in the evenings, you have another peak when people come home, depending on the season, air conditioning, heating kicks in, and you see another peak across the country, depending on the time of the day, that morning and evening peak. Here's an example of evening peak. You had windmills and other types of generation running, meeting that demand that we talked about earlier, and then all of a sudden the wind slacks off. They actually went into determining what level of emergency operations they had to do due to that. With the reserves there, they were able to stay away from operating under emergency operations. But there's a good example of reliance on specific types of generation. Again, I'm a supporter of windmill, so I'm not saying that. It's just we have to have a diversity of that. Next slide, please. This is an example of in Northeast. We had a tornado hit a tower. It actually pushed it, and then when it pushed it off its pedestal, off its structure, it sat it back down. This is a 500 kV tower. There was another one that was located a little further south in another company. Same thing happened, almost identically. During the time, we had thunderstorms, activities going on. I experienced this personally. We had a large restoration going on across from Ohio over to the East Coast. We had high loads. It was very hot, humid, as you can imagine, during this time period. The repairs of these towers, 3 days, we had temporary tower back up, a lot of good effort by a lot of good people. But this was unique because that line required other lines to be removed from service that could not be removed. We actually went into emergency operations, into curtailments of customers that volunteered to curtail load. We could not work on this tower during the day because we couldn't get clearance on other lines to do it. So the work had to be done through the night, and the lines that were removed for clearance had to be put back in during the day. So here's another example. Not a system collapse, not a major storm in the sense of millions of customers out, but we were operating from all three plants. Next slide, please. I'm going to go through this real quick. Basically, we talked about the difference in priorities when you change from a system issue into a more transmission, a system restoration event. And basically what this slide is showing you that you have units that are capable of starting other generating units up, a black start unit. Let's pretend that's the one down in the lower left-hand corner. You use the transmission facility, the bulk power system, to start up another unit that is required. That unit has to crank, and it has what they call ramping parts where they have to have so much load per minute to ramp up into a stable mode. Distribution load is used at that point to stabilize the power station. Then that power station is used to start other power stations across the system. The objective is to get, as you use load to stabilize units, is to get the bulk power system back in, get the generating units up and running, and then get the load on to support that, and also you have a quicker restoration. And we saw that in the Northeast blackout. You know, tree and 47 other issues caused that blackout. It dominoed. You should have also seen how fast the system came back up. Next slide, please. Kind of bringing this presentation to the final slide of questions and answer. When we prepare both in the distribution mode to transmission and generating, and so you have, as you see me doing it, I'm separating the three, but to talk to this, and you can see the complexity, you have to talk like that, at least I do. Prior to going in, you know, we do this year-round, but we really focus on summer and winter, and, you know, your high loads. What are you expecting this winter? What did we do last spring, last fall to enhance the system for capacity and et cetera? We do those studies. Those studies are projected out pretty substantially, 5, 10 years out there. We patrol lines on a routine basis, depending on the voltage. We may patrol some lines twice a year. We patrol lines in preparations for presidential inaugurations, the G20 summit, the Super Bowl. We don't just limit it to this type of situation. Coordinated outage schedules I talked about. In some cases, outages have to be scheduled a year in advance so that there's a good coordination between the ISOs and the RTOs and within the RTOs or ISOs footprint. And that's where the N-1, N-11, and -2 talks about contingency planning. I could spend a whole day on that, and I'm really not the qualified person to talk about that. Then you sit down and within a corporation, you talk about your summer readiness so that everybody within the different parts of your organization are on the same page. So then within our system operations, technology has gone to a point of we have real situational awareness tools, even down to SMDs. When we have solar flares that are raising the level of SMDs, our system operators are starting to be able to visually see that in front of them. Certifications and training, we have the NERC certifications, we have ISO, RTO certifications, and as many other professionals and jobs, you have continuing education hours. And that's exciting because the system operators really are training themselves. You have a plan, you have an agenda, you have a presentation, you have tests. But the thing is, what the discussion that goes on in there is so important to have that on a year-round basis. And the last slide is really for prettiness and to say, are there any questions or comments that I can help you with?
John, we have a number of questions here. I'm not sure we'll get to all of them, but we'll try. First question is, why do restoration fleets sometimes have to leave my state when the power's out in order to restore power in my state?
Well, as we discussed, and again, the reason why I didn't show you a map of the bulk power system is, that's, while it's out there and you can get it, it's technically critical infrastructure information that I should not be just posting out there for anybody and everybody to see. But let's talk about the East Coast. The flow of energy on the normal basis, and I would say probably, and I would look for somebody to correct me, 95% of the days out of the year is west to east. Our power over here, and due to the load, a lot of that comes from the west, the north, and possibly some from the south. You lose those lines, and we go into emergency operations, into starting to curtail voltage reduction, possibly rotational distribution. You want that priority in getting that grid back in. So that's why we'll reallocate resources, move, and those repairs require certain qualifications within those line personnel, those electricians, those substations, the controls people that work on the relays, and the engineers that designed this. So what we do is we try to, the worst case is we move them out and just send them there. The idea is we reallocate resources. We send that level of qualifications to that incident and reallocate resources into the ongoing restoration effort.
Good, thank you, John. Next question is, what types of events do impact the grid?
Well, our one slide showed that. I would not say that there's not a event that doesn't impact the grid. It just to what level? You think about your transmission lines. You see the structures that are down the road. You see the right-of-way clearance that are in those structures are built and aligned with standards that are out there both with NERC and IEEE, and I can keep on going with the standards that we align to and we adhere to and we comply to. The distribution, the right-of-ways, how many times do you go down and you see the distribution line running? The right-of-way is clear, but there's this 200-foot tree sitting off to the right-hand side. And, and you have that condition. So I don't want to say that there are not anything out there that doesn't impact it. You have weather, you have the solar flares that can impact it. You have just the load, and I hate to say this, but people, the society we're in now, you have sabotage, you have terrorism. So I don't want to say that there's any specific thing that wouldn't impact the grid.
Thank you. How are governments notified of grid issues?
As I talked about before, there's and I'm going to focus on my experience. And I had, throughout my career, I had some responsibility to NERC standard EOP 004, which I know there's some changes that are coming to, but that is reporting to FERC, NERC, your regional reliability coordinating groups such as RFC, the one I'm familiar with. You're reporting to your ISO, RTO, to your state agencies, through and to the federal government through reports such as the OE 417, which is a DOE report that goes from curtailments to load shedding to weather events. It encompasses a lot. So first of all, there's entities that have responsibility. There's also the ISOs and RTOs. When you're into these different plans, they're having communications with the governments. So our public sector needs to be engaged, especially the EMAs. They need to be the state EMAs. And I know in many cases counties are engaged in this, but engaged in those calls where those calls occur. And I can only speak for one area, the Northeast here. I know they do occur. I can't speak, but I assume that they do. In addition, there's communications that are related to these specific things that are already templated out in the different emergency plans. So we're sending a consistent message both from the regional transmission operator, or ISOs, and the electric utilities, so that we're sending a consistent message to our public sector and to our communities that are out there dependent upon this.
Very good. The next question is, how do the power distribution companies identify and prioritize critical assets for restoration? Is there an established process?
Is there an exact process that every single utility uses? No, because what we know for a fact is our processes are so similar, and we work with our communities. And you think about it, who's better to work with than your counties? And then we have an expectation. We also work with our states, and we also have an expectations from the private sector that our counties and states are interacting and understand the priorities. So when you have a state with many counties, and those counties all have their individual priorities, but we can't address each one, we work with the state and counties to create one list of priorities. Those priorities, we sit down, we discuss this with our government, our public sector. Okay, hey, we see this as a critical facility. That needs to be towards the list. We make sure we have it there. And then during the event, we let them know that first of all, we understand that this is a critical facility for some reason, and where it falls in our restoration effort, that gives them an opportunity to tell us, hey, this possibly needs to get moved up. So that stems from we started looking at water sewage. We started looking, of course, hospitals are right there, and nursing homes. There's a lot of different levels of nursing homes. There may be not as much requirements for nursing homes to have contingency plans. I don't know that for a fact, but all I'm saying is there's more and more critical facilities. You have government facilities that are doing things that have to continue that we have to be aware of. Not necessarily what they're doing, but we have to work with DOE, DHS, we have to work with DOD, we have to work with the federal agencies also to know and understand that this facility has some priority. Sorry, I can't. None of my answers are short.
Very good. Next question is it always the case that when the grid is referenced, that it's in relation to just generation and transmission components?
That's a very good question. I would say if you would poll that question, the answer would almost come back 90% yes. But if you ask me, when I talk about the grid to people, I do not exclude distribution. I make a point of talking that, hey, let's get specific. Here's when I talk about the system, the network, the system, the electric system as a whole. I'm talking about distribution, transmission, generation. What are we specifically talking about?
Very good. It wasn't specific in the question, John, unfortunately. Let's go to our next question here. Has the sector considered cyber and EMP attacks? Can you talk to that for a minute?
Yes, very much so. Cyber is on the mind, in the forefront of not just the electric sector, but everybody. Let's face it. We are so electronic that we have to. We worked with our associations such as EEIS and Electrical Institute on assessment. We worked with Department of Energy on a cyber assessment. We have, there's SIP standards, numerous SIP standards, and you can go into the NERC website and look at those standards that puts a lot of requirements, and rightfully so, onto the electric sector. We're learning from the financial sector. They're dealing with this on a daily basis, and we're having those type of conversations. We're monitoring. We have intrusions, the protections. When it comes to cyber, I'm not sure if you will ever have enough, but I would have to look to a cyber subject matter expert to take that question and answer it better. And electric disturbance, such as the nuclear bomb, we're focusing on that also.
Great, thank you, John. Another question is, are there any training sessions available for civilians? This person is a CERT member, would like some training if they could get it, if it were in some limited capacity.
I would say yes, there is, and I will check into this, Tom, and I have some avenues through both the state to check into this. I believe the RTO and ISOs would offer some level of training. So let me get back to you. I don't want to give you I want to say yes, but I don't want to say that with some documentation to send somebody to.
Sure. Next question is, do home generation of power like solar or wind provide much power to the system?
No. Unless you got acres and acres of windmill, what we're really dealing with there is, and again, I would have to bow down to a subject matter expert. As we move forward and more people have that, it's going to be it's going to have a little impact, but the level of loads that are on the system, that you think about what we just went through with this heat period that we just went through a few weeks ago. What people have is really more for them, and what they're doing is selling the excess to the utility. I'm not going to downplay it because we talked about distributed, and we continue to talk about distributed generation, which is smaller packages of generation onto a smart grid, and we're talking really in the focus of distribution now. And they're going to have an opportunity there to enhance that thought process.
Okay, John, there's several, probably 6 or 7 questions regarding solar flares and how well that's been studied. Can you comment on that?
I wish I could study on how well it's been studied. The electric sector, like I said, I retired from another utility after 35 years, and I spent 17 years on as a system operator dealing with the transmission, generation, and distribution. And throughout my whole career, we've been discussing, we have protection out there to some level for solar magnetic disturbances. So I think the studies are there. It has been massive. There is a satellite up there that deals with monitoring it, that gets that information back to us. I know it's running to the end of its life expectancy. I know that the government is dealing with that. Again, from my experience, there's been a lot of study, but that study has not ended. So I'm not sure if that was a very good answer.
Very good. Let's see. What are the methods used for public notification of curtailment or low voltage solution from the grids?
Those communications are done both by the ISOs, RTOs, through consistent messaging. In addition, the electric utility uses that same messaging to communicate. During heat waves, when we enter those, there will be public communications put out to our communities saying, hey, here's what we're dealing with. We're, what part of our emergency plan we may be in. We may be curtailing load with those customers that pay for that, and we foresee no other issues. In that case, that communication doesn't necessarily go out. We may do some internal curtailments all within our own companies, which we all have plans for. Again, well, we're not foreseeing a major problem. We're assisting in maintaining that reliability. But when we start getting into a threat of rotational distribution or load shedding, we're going to be out there communicating and explaining how that's going to go. And remember what I said earlier, load shedding is that unexpected event where you don't have time to make that notification. You would dump the load, you would go into a rotational distribution interruption that spread that interruption across many people at a shorter period of time, and then you would implement a communication on that. So in some of those incidents that you don't have time to notify, the communication comes out afterwards.
Very good. We have time for just a couple more. There's many more that we can get to today, unfortunately. Can you discuss the role of advanced microgrids in plans and activities?
Boy, you've shown my limitation here. I could run within our company to many people that could talk to that question. When we talk about microgrids, I'm assuming we're talking about more of the distributed generation that I kind of talked about, where you have communities that are running off a small generator that's located in their community, and they're running like a small smart grid. But I have a feeling that question may be bigger and higher in voltage, so I have to stop there with my answer.
Okay, that's fine. How might a New Madrid earthquake of 7.0 or greater affect the East Coast grids and transmission, in your opinion?
That's a good question, because, you know, ground moves. We've had towers that were affected by landslides, we've had, and I'm going to talk about something that somebody's going to say, why in heck is he talking about? But we had a situation where we had massive undermining, where, and I don't know the technical name, where the ground actually drops down after the miner goes through, and you actually end up with possibly a 6 or 7 foot level. And what we had to do to prepare for that type of event in advance was so enormous. So our structures will withstand some level. I can tell you there's going to be damage. There is slack in the lines, but you know, you're going to have, depending on where the earthquake is, underground may be affected more in that type of scenario, where your network systems are, you know, underground and the ground is shifting. You have that less capacity to possibly flex in those type of cases. So again, I guess I hit my limit as a subject matter expert.
That's okay. John, we'll have one more question here. We'll try to answer all these if we can afterwards. Let's see. You talked about matching generator capacity to load with surplus capacity being built into the system. Is there a standard capacity overage, if you will, for a system in relation to the projected loads?
Yes, there are requirements out there that requires that you have levels of reserves that are basically, in many cases, could be generators spinning, and you have some generation that has the capability of doing that with no load, or you bring on more generators and load them up less, and you're looking at different levels of contingency planning on that. So, and then in addition, you have reserves in the sense that you can shed load. So while we try to stay away from shedding load as much as possible, because that's not our objective, there is that type of reserve that, you know, by shedding load you can do that. But what we're talking about is generation that's online, that's lightly loaded, that's in its stable mode, that if we have an unexpected loss of another generator for some reason, those generators will automatically pick up the load. Now remember, generators aren't where the loads are. And let's face it, I don't think people will want a generator again in their backyard. So now you're dealing with the transmission of that load. Again, that's considered also. So it's not just the reserves. You're talking about capacity of the lines and where you're at there. So the planning people, both at the RTO, ISO, and also at the transmission owner side of it, and operators, they go into great detail making sure we have reserves in different descriptions out there to respond.
Very good. Well, John, I just want to thank you for taking the time to put this information together. I want to thank all of our attendees who attended today. A link of this, of the deck slides, as well as the audio recording, will be sent out to all registrants here in the near future. Again, we thank everyone for attending, and John, thanks again for your time and energy on this. This will conclude our webinar for today. Thank you.
Thank you.